Hello guys, so I have this interesting sum over here. 1 cube plus 2 cube plus 3 cube plus 4 cube plus dot 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 plus n cube is equals to the square of 1 plus 2 plus 3 plus 4 dot dot plus n. So in other words, in mathematical terms, the sum of the cubes of the first n natural numbers is equals to the square of the sum of the first n natural numbers. So this might seem like a coincidence, but I can tell you it's not, it's just math. And I have two proofs for that, two methods. So first, this is a telescope. So we're going to use the telescopic sum method, which is just reliant on algebra. And this right here is a square. And we're going to be using a geometrical logical approach to see that this in fact is a square. So let's start with the geometry one. So for the geometrical proof, we're going to need some kind of formula first. So here we know that the sum of the n natural numbers is n plus 1 by 2, and this is going to be whole square. So if you open that up, it's n square, n plus 1 whole square plus 4. So we're going to need this formula for the algebra one, or we're going to derive this, and for the geometry one, we're going to focus on this. So we have to make a kind of a square using this formula over here. So for the cubes one, I'll represent it by an object. So the first number is 1 cube, so which is just 1, and I have 1. So the sum is 1, area is 1. Now let's start with the second number 2. We have 2 cube, that is 8, and I'll represent that number by a cross. So I'm going to lie a cross like this over here, 1, 2, and another one right here. And that means I've used the 4 out of 8 crosses. That means I have 4 crosses left like this. And as you can see, we have made a 3 by 3 perfect square. And this is 3, this is 3, 3 times 3 is 9. And 1 cube plus 2 cube is also 9. So we're kind of getting a pattern over here. Let's go with the third number and let's represent it by a circle. So that means we have 27 circles over here. So I'm going to lay 3 over here, 1, 2, 3, and here also 1, 2, 3. And let's just fill in. 1, 2, 3, 1, 2, 3. 1, 2, 3, 1, 2, 3. And over here, we can perfectly fit another 3 by 3. And this is also a perfect square, because we have 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6. So for this length, we have 1 plus 2 plus 3. And for this, we also have 1 plus 2 plus 3. So if we keep on increasing the number, we can see we'll have 1 plus 2 plus 3 plus the next number will be 4, then 5 plus all the way to n. And similarly, that is the same case for this length over here, which is the same. And we know this, the sum of n natural number is just n plus 1 by 2. And this will also be n plus 1 by 2. So that means the sum of cube of n natural numbers will always be a perfect square where the length is just the sum of the first n natural numbers. So that means this 1 cube plus 2 cube plus 3 cube plus dot 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 plus n cube is equals to the area of this square, which is a length square, and its length is n plus 1 by 2 and whole square. So this is for the geometrical proof. Now let's move on to the telescopic sum method. So for the telescopic sum method, we're going to have to use a kind of an identity, which is that r4 minus r minus 1 to the power of 4 is equals to, well, let's just calculate this over here. So r minus 1 to the power of 4. I'm going to use Pascal's triangle for that, since I don't want to do much algebra. So 1, 3, 3, 1, 1, 4, 6, 4, 1, and since this is minus, it will be minus minus. So over here I'll have r to the power 4 minus r to the power 4 minus 4r cubed plus 6r squared minus 4r plus 1. And when I open the bracket, this and that will cancel. I'll have minus minus plus 4r cubed minus 6r squared plus 4r minus 1 to find the formula for the cubes right here. Well, here, what is r? Well, R is just the set of natural numbers. It could be 1, 2, 3 and so on. And it can be n as well, which we're trying to find. So let's take the cases when each of them are 1, 2 and 3 and add them up. So let's take it when R is 1. So wherever there is R over here, just put 1 and you'll get this. And next choose R equals to 2, so you'll have this. And again put R equals to 3, replace everything with 3. Oh wait, no, not everything, R with 3, like this. And so on and so forth. So you can do all the way up to n. So you'll have n4 minus n minus 1 to the power 4, 4n cube minus 6n square plus 4 into n minus 1. Now, as you can see, I have an alternate kind of series over here. So if I add them up, I can see this, that cancels, this and that cancels, and then in the next that and that will cancel, and that keeps on happening. So I'm going to add all of them up. And as I said, this, that cancels, this and that. And at the very end, I know that this and this will somehow cancel. And I'll just get n to the power 4, which is here. At these terms, I can take 4 common and I'll have 1 cube plus 2 cube plus 3 cube plus dot 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 n cube. And this series over here, that is what we're trying to find. And we'll have here minus 6, take common 1 square plus 2 square plus 3 square plus dot 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 n square. And this is plus 4, 1 plus 2 plus 3, this would be 3 plus dot 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 n minus 1 minus 1 minus 1, and there are n number of 1s, so this is just minus n. Now I know the formula for the sum of squares of n natural numbers. I also know the formula for this, and just doing algebra we can find the formula for this series over here. So I'm just going to put in the formula over here. So I'll have 4 into, let's call this series Sn, and we're trying to solve for this. Minus 6 into, this is n plus 1, 2n plus 1 by 6, and here 6 and 6 cancels nicely, plus 4, this is n plus 1 by 2, and also 4 and 2 cancels nicely, and remaining is 2 minus n. So I'm just going to isolate the Sn part over here and put everything over there. So I'll have n to the power 4 plus n plus 1, 2n plus 1 minus 2n plus 1 plus n is equals to 4Sn. And I'm going to write over here. So I have this, and here I can see I can take n common from all the terms, so I'll just do that. And in the next step I can see from here and here I have n plus 1, so I'll just take that common. So I'll have 2n plus 1 minus 2 plus 1, and this I'll have in the next step n cube plus n plus 1 into, this is 2n minus 1 plus 1, and I'll just open these brackets over here and distribute them. So this is n cube plus 2n square minus n plus 2n minus 1 plus 1. Nicely, these will cancel, and I have over here minus n. So, oh sorry, I'll have plus n, and I can see again I can take n common from all of these, so I'll have n square bracket n square plus 2n, this is plus 1, and we know this n square plus 2n plus 1, it is just the formula for 1 plus x whole square. A square plus 2 into a into b, which is 1 plus 1 square. So we have 4Sn equals to n square, n plus 1 whole square. Therefore we have Sn is equals to n square, n plus 1 whole square by 4. There we go. We proved it in 2 ways that in fact this is not a coincidence, it's just math. And if you guys learned something new, please like and subscribe. Thank you.